Hey everyone, this is Andrew. I'm doing a teaching unit based on a lot of stuff. It's in order to make me learn more about what I learn, to learn by my learning. That's pretty meta. However, other people can benefit from this, especially when it comes to rate of change. Kind of in mathematics, kind of in physics, lots of applications. The rate of change, in my words, is the ratio of movement for values. There's slope, which is the linear rate of change. There's secant lines, which shows the average rate of change, and then there's tangent lines that show the exact rate of change within 1 point. Secant lines do 2 points, tangent lines do 1 point. There's a lot of rates of change, specifically with functions, because they change depending on their values, depending on their degrees. We can look at circles to find out how they're changing, but that's a whole different story. What we're learning about is the derivative. In calculus, that's the instantaneous rate of change for any value x. You can find the function for that by using lots of rules, lots of things, such as limits, using the difference quotient. But more on that later. When we're looking at graphs, they change in slope differently. This doesn't change at all because it's a linear function. It has a constant rate of change. This quadratic function changes, of course. So it has a different value than this value. Because when you differentiate this function, it's always going to be the slope. If you differentiate this function, it's going to be the slope for 2x. So if you plug in a value, you're going to get the slope based on that x value. When we're looking at cubic functions, we're finding a different value. Because the change in velocity, or the change in the rate of change, changes for this function, but not in this function. Why is that? It's because it's going through a certain trend. Because if you differentiate this, it's going to look like this. It's going to follow that same rate. If we use different terminologies, we can find velocity. Velocity is the rate of change. Acceleration is the change of velocity. That's interesting. So velocities change based on how it moves, because it's changing in speed, or changing in velocity, rather. This is not, because it is going the same rate. This is changing because it's going different rates. So you can make a division between these within this line of inflection, or a point of inflection. It changes. It kind of looks like it's a quadratic going like a function. That's how I see it. But it's changing. This function, which is a quartic function, a degree 4 polynomial, it's changing. Really, it's changing. But it's changing in acceleration. Well, this is also changing within acceleration. This is changing the change in acceleration. So that's a lot more interesting. So the change of acceleration is also known as the jerk, or known as jerk, or jolt. But jerk is a really horrible name. It's the change of acceleration. So not really famous, but it's interesting. Jounce is also interesting because it's the change in the change of acceleration.